Good evening, world. Welcome to the Amateur Astronomers Association's Moon-topia. I'm Irene Pease here with the Amateur Astronomers in New York, and this is Moon-topia, our monthly edition exploration of some of the fabulous, marvelous satellites of our solar system. There's so many, so every now and then, once a month or so, we check out a couple of them in kind of virtual land. So that's what we're doing tonight. You can follow the Amateur Astronomers Association on social media at AAADOTORG. You can check us out on our website, aaa.org. And we are going to be doing several events around the upcoming conjunction. So I'm not going to talk terribly much about that tonight, just a smidge, because we're going to have several live streams. And I'll go ahead and put that link in the comment section so you can check that out. The visuals that I'll be using tonight, right now in the background, you see OpenSpace. You can find OpenSpace, download it for free, play around with it, super fun. That's at openspaceproject.com. And in just a moment, we'll be switching over to Stellarium, which I like to use for kind of planning, observing, using in the field, etc. You can find and download that at stellarium.org and also find it at the App Store for your devices. So Moon-topia, first edition. We've had multiple Moon-topia sessions, but this month we're doing the first edition. We want to look back at the first moons other than ours that were observed, that we knew about. So let's go ahead and jump on over to Stellarium and we can see what's happening with that. So I think we're looking at now. I try to start with now, the 14th. Yeah, that's today. And we're now. Actually not quite now. Let's see if I can get this closer to, yeah, now, because it's dark in Brooklyn. So this is viewed from Brooklyn. It's part of NYC. That's where the AAA is. And kind of looking over towards the west and southwest, I am going to rewind time. So if you didn't see them earlier this evening, I think there was a pretty spectacular sunset in the New York City area, but kind of cloudy. So I'm not sure if anyone got to see the planets this evening. So if you were out and if it was clear, you would be seeing some very bright spots right above the southwest part of the sky, right above that SW. The SW will not appear on your horizon, but all these dots, depending on what kind of light pollution situation you have, these dots may or may not appear in your sky. The brightest dots, these two, will appear in your sky. These you can see from Times Square if there weren't buildings in the way. So if we zoom in there, I've kind of taken off the labels so you can kind of guess, because every single month for the last several months that we've been doing Moon-topia, we've talked about these two objects in the sky as they've been getting closer and closer. So let's just review just a little bit, all right? So Moon-topia from a few months ago, they were a little further apart, and it was bright out. I just really like this view of Brooklyn, Mount Prospect, Gowanus over there. Yeah, so at this point, they've gotten quite close. So if we, oh yeah, daylight savings happened. Don't get me started. All right, so they've gotten quite close. They used to be a little bit more separation in the night sky. And then over the last few months, this has happened. Wow, look at that. Closer and closer. And every time our moon swings by, we do Moon-topia. So there's a reason for the Moon-topia. And this month in particular, we're going to have There Goes the Moon swinging by again this next week. So that means it's time for another Moon-topia. So tonight, this is tomorrow, 2 nights from now, our moon will be a crescent over in that part of the sky. And you guessed it, we're zeroing in on Jupiter and Saturn. So if you look, they're getting quite close. And the question is, how close is close? So astronomers might talk about, oh yeah, these are going to be really close in the sky, and isn't that exciting? And yes, it is, but what do we mean by close? So you look up in the sky from far away, and it's like, yeah, those are pretty close. I mean, line of sight close. We know they're not really that near each other in space. But what about these stars? Are these close? Like, how close do we mean when we say close? So I'm going to show you an image of that. Actually, let me just flip over to OpenSpace to show that image. So I brought up, oh, not that one. I brought up a beautiful image. That one. um, so this image of a full moon. Okay, so this isn't what it's going to look like in the night sky because it's not going to be a full moon this week. You're not going to see the planets in front of the full moon. That never ever happens because our moon is closer to us than the planets. But just to give you an idea of how close is close, how close is this alignment, this syzygy. Thank you, Chris, for that favorite astronomy word of mine. So starting like the 17th through the 25th. So the 17th, they're definitely going to be close enough that they would fit within the space of a full moon. The 18th, there's Saturn, there's Jupiter, there's a bunch of moons in between. That's what we're going to be talking about tonight. There's Jupiter, Saturn, Jupiter, Saturn, Jupiter, Saturn. So that's the main event is on the 21st. Hoping for no clouds, right? And then they're going to get further and further apart again. But kind of from the 17th through the 25th, they're going to be close enough that they would be closer than the width of a full moon in our night sky, right? So just kind of a sense of how close do we mean when we say close? That's really close. Close enough that they both fit in the field of view of a telescope, a relatively smallish field of view. Full moon is kind of a wider field of view. Part of a full moon, like in here, that's a small field of view. So that's a really exciting thing that doesn't happen all the time, happens actually quite rarely. And so that's what we wanted to take a look at. Did Galileo see this? Possibly not. Back in the last time they were this close, 1623, it was very close to sunset. And so we may not have actually been able to see it in the sky. They may have been too close to the sun, too close after sunset, and it may have just been too glaring. But he would have had a telescope that could have seen this. If we zoom in, his telescope was probably around 1/4 of a degree. So I kind of turn this down. So something like that. So actually, if I center on here, center on our Jupiter, and go forward a few days to the 21st, Jupiter, and on the 21st, sorry, find my Jupiter again. Yeah, if we take this down to the field of view, magnify it to kind of what Galileo would have been seeing in a telescope, or anyone else who had a telescope, he wasn't the only one, they would have been able to see these in their telescope if it wasn't too close to the sun. All right. So obviously safety first, never look directly at the sun, all that. But that shouldn't be an issue for this coming alignment. So I just want to pause time for a moment. So again, tonight, just to kind of prepare you for a view, it's not just the planets, but it's their moons. So he talks about some of Saturn's moons on different moon-topias. I think that's not actually a moon, that's a star over there. But then we have the 4 Galilean moons. And so those are what I want to talk about tonight. First edition, those are the first moons that we found orbiting around another planet. So those are pretty exciting. Was Galileo the first one to see them? Dunno. Galileo is the first one to publish, and so that's why publishing is so important. Yeah, that's why a lot of people rush to publish, because the first to publish usually gets the credit. So Simon Marius may have actually seen them first. He says he saw them first about a week before Galileo did, that he saw Jupiter in the telescope and saw these moons going around Jupiter, at least saw them in the telescope. But he didn't publish until after Galileo. So who do we know? We know Galileo, not Marius. Sorry, Marius. Anyway, so these are now called the Galilean Moons. Galileo didn't call them the Galilean Moons. I believe he called them the Medici Stars after his sponsors because, got to pay the bills. And I want to just take a few minutes to stop by each one of those. But even just looking in Stellarium, we're going to get to like the real data in open space momentarily. But even in Stellarium, you can see a little bit of a difference in these moons. So we have Io, Europa, Callisto, Ganymede, and some of them are slightly bigger, some of them are slightly smaller, brighter, darker, more or less reflective. And there actually could be ways to tell them apart. This is a life goal of mine, to be able to tell them apart in a telescope without looking at my Stellarium app to tell me which one is which. So if I ask Stellaria, well, which one is this? it'll tell me, oh, the close one is Ganymede, right? So even though Io and Europa orbit closer to Jupiter, those are closest ones in, and then Callisto, Ganymede are further out, but they're all going around Jupiter, so they all appear different distances from Jupiter. So I'm guessing this is Io, partly because I checked earlier, and partly just because it's a little bit darker in hue. And then there are ways to tell which ones are Callisto, Ganymede. So just real quick, if you want to try this, remember the brightest ones are actually the smaller ones. So the smaller ones are more reflective. So if you look, the two brightest looking things should be Io and Europa. And then the dimmer ones are going to be Ganymede and Callisto, where Ganymede looks a little bit larger and Callisto looks a little bit smaller. And to me, Io looks a little bit darker and Europa looks a little bit lighter. If you can figure it out, great. If you practice, maybe in a decade you can do this. I've known people that supposedly can do this. I'm still working on it. But just a fun thing in all your spare time the next time you're observing. So just to kind of get a sense of what these actually look like in real life, let's kind of pop back over to open space. And I think I have another picture to show. Yeah, that's the one. So there they are kind of side by side. We never see this in real life, right? But these are their relative sizes and kind of colorized images. So again, I mentioned that Io and Europa appear brighter. They're more reflective, and you can see Ganymede and Callisto are darker. They're less reflective. So even though these two are smaller, they appear brighter. And then even though these two are a little bit bigger, they appear a little bit darker. Just for reference, our moon is kind of between the size of Io and Europa. So a little smaller than Io, a little bit bigger than Europa. And while we're sorry, I'm just looking through some of the comments. And while we're at it, let's go ahead and just check them out. So that's what I wanted to do in open space tonight, was just take a stop by each of those. And those aren't moving around Earth, so I guess we'll have to move away from Earth and head over to Jupiter. So again, open space, you can download this at openspaceproject.com. And you can kind of fly around the universe in 3D. This is all real data, so real images from missions. We've had several missions past Jupiter and its system. Let me just go ahead and turn on some of the orbits so you can kind of see the Galilean moons, or the Medici stars. We'll just call them the Galilean moons. Those are the 4 largest moons of Jupiter. It has a lot more. And but those are the largest ones. Those are the first ones that we saw through a telescope. And actually, if I just go ahead and look at Jupiter kind of edge on, I'm going to do a fun thing here. Or, you know what, we can do that from we can do that from Earth. I want to kind of go through time a little bit and see how they look when they're orbiting Jupiter. So they move some of them move quicker than others. Let me just set some time, and yeah, off we go, right? So closest in, Io orbits in less than 2 days, about 1 3/4, so 1.75. And then next out is Europa orbiting every 3.5 days, and then next out is Ganymede orbiting every 7 days. So those are actually in resonance with each other. So 1.75, 3.57, so that's a 1, 2, 4 resonance. And then Callisto is just kind of doing its own thing. So the inner 3 have this resonance, and so they get kind of these extra effects, which is interesting. I'll talk a little bit about that. Basically just extra tidal effects. But just by watching these from the side view, Galileo was able to figure out that, how long it took each one to move around. So you could watch them over the course of an evening and see them change positions a little bit. And you could also check in on them from one night to the next. and see how their positions have changed and figure out like that these are 4 different things. They're all going around Jupiter, and he was able to figure out the rates at which they were going around Jupiter, which is pretty exciting. And we can still do that today if you want to watch it every single night. Which it looks like a lot of people have been watching the planets. But if you have telescope or binoculars, you can pick out the moons of Jupiter. So some of the brighter things you can see through relatively low power optics. So these have been visited by the Pioneers, the Voyagers, the Galileo probe. Cassini and New Horizons both did pass-bys of Jupiter. And most recently, we've had the Juno mission there imaging Jupiter and its satellites. So let's go ahead and just start off with Io and zoom into that. I want to go ahead and just turn on all of Io in here. So we kind of turn off the shadows, the fun effect that we can do in open space. So these are, this is a map from actual images from all these missions. So we actually have pretty detailed maps of these larger moons of Jupiter. We've been studying them for a while. So Io, again, it's just a little bit larger than our moon, a little bit bigger than Luna, and is the most volcanically active world in the solar system. So almost all of these moons are like record setters. So it's kind of like a really awesome team going on here. Io is one of the most dense moons. It's actually very dry. So even though it has volcanism, it doesn't have like the same types of volcanism necessarily that we have on Earth. A lot of volcanic activity that we have on Earth is due to plate tectonics. So we have like the Ring of Fire that's all around like some tectonic plates on the Earth, and that requires water as a lubricant so the plates can like slide over and under each other. But Io is actually very dry. It has very little water as a percentage, and so not that kind of activity happening. But instead, it's mostly tidal forces. So in resonance with its 2 neighboring moons, Europa and Ganymede, and then being so close to this behemoth Jupiter, it gets kind of stretched and squished a little bit. It is tidally locked. All 4 of the moons are tidally locked like other large moons in the solar system. So the same side is always facing Jupiter, but there's still like a little bit of wiggle there. And it's still getting kind of churned up. I can just imagine its insides being mush most of the time. It has kind of a patchy atmosphere, so with all these volcanoes going off, they're mostly giving off a lot of sulfur dioxide, so it has like a very, very thin kind of regional, I guess, atmosphere of sulfur dioxide. And because of all this stretching and squishing, it has all these mountains, several mountains that are even higher than Mount Everest. So some pretty extreme terrain for a moon. It's just a little bit larger than our moon, but lots and lots of volcanic activity. So kind of interesting, kind of exciting there. The next moon out, Europa. We can zoom to Europa. And I need to perform shading. Europa. There it is. Oh, Europa. So Europa, pretty exciting. It's very different from Io. Very different. They're almost like day and night different. Instead of being super volcanic, it's actually very smooth. Not a whole lot of mountains, but similar in that it has a newer crust. It actually has a newer surface than Io. So we think that parts of the surface are only 20 to 180 million years old, so less than a billion years. And like I said, it's just a little bit smaller than our moon. We think that there's a lot of water below its surface. We think it's very icy on the surface. And so we have cryovolcanism there, which is something, again, that we don't have on Earth. Kind of the other main example of cryovolcanism that we see in the solar system is Enceladus out by Saturn, which I think we've visited before on Moon-topia. We might go there again sometime. Very, very thin atmosphere, maybe just a little bit of oxygen. But it has layers, like all the Galilean moons have layers, probably a nickel iron core and it's kind of a silicate mantle, but just this huge ocean beneath the surface. So these lines may actually be from small eruptions, like where the ice kind of cracked apart and kind of ices were able to erupt and flow out just a little bit. And so there may actually be more like tectonic activity down at the bottom of the ocean, the lower part of the crust, not so much on the surface. That's kind of its own thing. And it may even be rotating at slightly different rates. So, like if the exterior, which is more tidally locked, is rotating at a slightly different rate than the interior, that could turn up a lot of chaos that could lead to more tectonic action down below. So in the interest of time, well, there's also these interesting spikes near the equator, which we can't see from this latitude, but you can see kind of those scratches of where ice may have split. So very, very smooth, one of the smoothest objects in the solar system, smoothest worlds in the solar system. Again, a lot of the little moons are just like fluffy, rocky things and not even necessarily round. They're just like oblong and all over the place. But Europa, very, very smooth, very lovely. And then on to Ganymede. So let me pop that one in here. Ganymede. Just whirling around the Jovian system here. So again, Ganymede, that's the last one of this triplet, the last of the three that are kind of in residence. So Ganymede has kind of two different types of surfaces. It has like those darker regions, the main one in the north, that's the Galilean region, and then it has these lighter regions. So the darker areas, more heavily cratered regions. So if we kind of zoom in there, we can see, we kind of look at the difference between those. So we see craters on both parts, but you can see like these like bigger, like older craters. So this would be like a newer crater in here. So a lot more cratering, like older cratering on the darker parts, and then the lighter part, slightly younger, not a whole lot younger of a surface, but that has more of these grooved areas, and that's where we find more of the ices. So we think that there also could be some water trapped under there, some kind of ocean under there. But that may have actually deposited some salts on the surface. So some of the chemicals they see on the surface, different combinations, different salts that may have oozed out and been deposited by oceans beneath. The other things that I thought were really interesting about Ganymede, apparently has a non-negligible magnetic field, which, I mean, it kind of gets washed over by Jupiter's magnetic field. Jupiter has like a tremendous magnetic field. And so that kind of dominates the system. But Ganymede also has its own little magnetic field, and it has polar caps. I didn't really see too much of the feature, like looking at some maps. I think I saw a little bit of what I might imagine is a polar cap towards the southern end here. Make sure I'm looking halfway in here. But yeah, it does have polar caps. It doesn't really go through seasons so much. So they're not going to like expand and shrink, but there are, I guess, more ices built up in the northern and southern parts of Ganymede. So that's the excitement of Ganymede, kind of a dual surface, the dark areas that are more cratered, the light areas have more salts and ices, and even the super fun caps, because everybody needs a hat. Ganymede came with a hat. Thank you, Ganymede. So last but not least, we're going to zip on over to Callisto, which, as I was looking at these, I decided Callisto is my favorite for today, at least. Of these four, I think I was most impressed with Callisto. One, I think I just kind of like that, I don't know if it's like a little bit of a rebel, that it's not in resonance with the others. Like, oh, you know, doing its own thing out there. And then also just that it is pretty big, but it's the least reflective. So it has the lowest, what astronomers call albedo, just the reflectivity of the surface. So although it's bigger, you think it could be brighter, but really it's got these really dark features. So it's not as hot on the inside. There's less tidal heating than the other three, but it has a little bit of an atmosphere. a little bit of carbon dioxide, a little bit of oxygen floating around up above the surface. It has the oldest and most cratered surface of any world in our solar system. So that I found fascinating, especially in contrast with Io, right? So Io is over there zipping around, super young surface, Europa, super young surface. And then out here we have the oldest surface, just like right nearby. So just the variety of the contrast of these four moons is incredible. I may have covered this one when I talked about Death Stars. It has a couple huge craters. And that's one of the neat features that I really like about Callisto is these like the nested ringed craters. The two largest ones are named from Norse mythology. So I believe this is the largest one because it looks really big. Valhalla, which is over 3,800 kilometers across. So huge. And then right next door, if we swing around a little north and west, we also have Asgard. So again, if you know Norse mythology or if you watch a lot of Stargate, you might recognize those names, Valhalla and Asgard, as these largest craters, and these just the beautiful rings in those craters. It's incredible. So Callisto also has like whole chains of craters. It's just like craters upon craters upon craters. It has some frost deposits, and it has those two amazingly huge, ringed craters. So Callisto, kind of an oddball, kind of interesting, old and antique-y, and I don't know, Norse, I guess, but I guess that's kind of a human artifact. So those are the 4 Galilean moons. Again, probably not necessarily first seen by Galileo, but we just call them the Galilean moons. And what's up with calling it by his first name? It's like Cher, like Galileo Galilei. No one ever says, oh yeah, Galilei. But, we say Einstein, we say Hawking, but we don't say Galilei, we say Galileo. So he's, I guess, kind of a rock star like that. Anywho, those are our Galilean moons, and I just want to mention a couple other things before I zip out of here. No dinosaurs on Callisto. Yeah, not that ancient. No life there. So if you want to see these moons and some of the moons of Saturn and Jupiter and Saturn, AAA is going to be having multiple live streams around this whole event. You can find information on the main website, aaa.org, and as promised, I'm finally dropping the other website, the specific website in here, Conjunction 2020 at aaa.org. So you can check that out. That'll have information about the live streams we'll be streaming here on Facebook, as well as on our YouTube channel, weather permitting. All right, folks. So we do not have that wonderful cloud zapper. We are saving up for one, but it's not here yet. Maybe next year we'll have our cloud zapper and we'll be able to look through clouds. But for this week, we're just, beholden to the weather. So if the weather's clear, we plan to be streaming this Friday, Saturday, Sunday, Monday, Tuesday. It's a whole week from now, from 4:30 to 5:30, again, on our YouTube channel and as well as Facebook, right here where you are right now, if you're watching this live. So check that out. Information on the website. We'll be updating it over the course of the week. You can also just check out aaa.org for all the other fun things we have coming up. We have lectures, we have classes starting in January again, and follow us on all the social media things to stay updated on that at aaa.org. Thanks again to the visuals that we use. We used OpenSpace, which you can find at openspaceproject.com, and Stellarium, which you can find at stellarium.org. Again, I'm Irene Pease with the Amateur Astronomers Association of New York. Thank you so much for joining us for another fun episode of Moon-topia. I want to wish everyone clear skies, get out there, see some stuff, and be safe out there.